Hi, I'm Alan Tian, and this is Bitcoin and Blockchain Unchained, kind of like MTV Unplugged. I've been working at PayPal and Visa for the last 10 years, so sort of an expert in the financial services space. Each of those companies were massive disruptors and innovators in their financial space, respectively. I bought my first Bitcoin on February 23rd, 2014 for a mere $665. At the time, I thought it was way too expensive. I bought it just to see what the hype was all about, learn about the technologies, sign up for the Bitcoin wallet called Coinbase. Good thing was I forgot about it for 3 years until I started seeing the news and Bitcoin was at $6,000 in October 2017 and it just kept on rising $1,000 a day. It hit $19,000 at the end of 2017. Well, that got my interest back real quickly. When I was at PayPal and Visa, I dismissed Bitcoin as something used by drug dealers and arms smugglers because it was really easy to use and it was untraceable. It was anonymous. But I didn't think it was usable by real companies, real people, because it wasn't a real threat to PayPal and Visa because the government regulators didn't regulate it at the time. Well, the rise of Bitcoin to these astronomical levels and the fact that it's only at $6,000 today seems to be there's something going on in all this hype. But there's also ICOs, initial coin offerings, kind of like IPOs for company shares, except these are issuing tokens, the coins. ICOs have raised over $13 billion in the first half of 2018. So this is some serious cash. And so a lot of my friends have been getting into blockchain. I wanted to learn more about it, and that's what's the output of this video. Hope you enjoy it. So there's a ton of hype going around with Bitcoin. Nobody knows what's going on, what the price should be. But the underlying technology of Bitcoin, blockchain, is very interesting and it's very powerful and has the potential to transform a lot of industries, whether the financial services industries or all the others over time, much like how the internet has transformed everything that we know about today. So only a few months ago, I knew nonce about blockchain. That's a joke. Nonce is one of the jargon terms used in blockchain, and that's one of the examples I will try to decode in this video. So Visa started in the 1950s as a Bank of America card. Did you know that? And it was a cashless revolution when it happened. So fast forward 70 years later, and it's ubiquitous. Everybody uses it. This tech adoption cycle that we were seeing is really accelerating tremendously in the last couple decades. Think about it. The iPhone only came out 11 years ago. I started working at PayPal in 2002, just before the eBay acquisition. I was there to celebrate the 10 million user mark, and now there are over 150 million. Really the best group of people I ever worked with. They're known as the PayPal Mafia, and they really had a tight culture. The thing that drove everyone was this vision to democratize payments, to basically remove money from the whims of government fiat money, where they could just pump out money anytime they want and cause inflation. Look at Venezuela today. This beam money part, which was one of their first ideas to beam money between Palm Pilots, really had to wait another 15 years for Apple Pay to make it work. But PayPal still relies on the traditional payment rails and still processes government fiat money. So let's see how Bitcoin works as the next step in democratizing payments. In October 2008, this guy or group of people named Satoshi Nakamoto, nobody really knows who they are, they're anonymous, kicked off this whole Bitcoin craze by writing this white paper and then implementing it over a year about Bitcoin, a peer-to-peer electronic cash system. Peer-to-peer is kind of like Napster, where they shared music between computers without a centralized server. So the abstract, if you read it, is pretty amazing. A purely peer-to-peer version of electronic cash, which would allow online payments to be sent directly from one party to another without going through a financial institution, meaning without going through a bank. So I highly recommend you download this document online. You can search it on Google and read it. It's very readable. So this vision is very similar to the PayPal vision, except the technology has caught up so they can actually implement it. But first, let's take a step back and see what is money and why do we need to democratize it to begin with? So what is money? We use it all the time, but we seldom think about what it really is. Well, this philosopher Aristotle, you may know him as Alexander the Great's mentor and philosopher of many different things, actually thought about money. And he wrote down 4 characteristics of money: durability, portability, divisibility, and intrinsic value. So durability, will it last through the wash? Is it portable? Is it easy to move around? Is it divisible? Can you split it up into smaller parts like coins? And does it have value by itself? So it's kind of easy if you look at, when you first started trading sheep barter, it wasn't really portable or divisible, but gold could be, and US dollars, or fiat currency could be. Well, you look at the digital coins and it checks all the same boxes as current fiat currency. So modern definitions, kind of ones that Mark Andreessen and such use, have added a couple more. They've replaced intrinsic value with like acceptability. So even though a US dollar piece of paper doesn't have much intrinsic value, it's accepted by everybody and therefore it has value. Now, one of the things that we see is limited supply. And this is an issue because fiat currency issued by governments like the US government is they can pump out as much as they want. So there is no limited supply. They can just keep on pumping out money when they feel like they need it. And they call it quantitative easing. Well, that causes inflation and sometimes hyperinflation. So one of the huge benefits of Bitcoin is that there is a fixed amount that will ever be made. And so that limits this risk. So if we look at the different attributes of money, we can say, yeah, Bitcoin's a viable currency, as viable, if not more, than fiat currency like the US dollar. So now we're saying, I don't know what the value of this thing is because it goes up and down and there's a lot of speculation right now. So let's put that aside for a second and look at the technology underneath it. It's called blockchain. So we will spend the next couple of slides deconstructing what blockchain is. If you look online, this is a typical definition of blockchain. A blockchain is a decentralized, distributed, and public digital ledger of cryptocurrencies. Now, that's a bunch of gobbledygook to me, so I've deconstructed this. So let's take a look at each of these words. Decentralized, as opposed to centralized, like being run by one entity such as Visa. Distributed means it's spread out over a lot of computers. It's not just on one basic big computer or a network of computers like Amazon or Visa. Public, as opposed to private, like banks. Digital, as opposed to physical form, like paper. It's a ledger, which really is just an accounting record of transactions. Crypto is cryptography, which is really a bunch of complex math to secure the data. And cryptocurrency is the new phrase as opposed to fiat money. Let's further define some of these terms. So the left picture shows what most common systems like Amazon and banks use today. A centralized and not distributed system stores the master ledger in one place, in that central server sitting in the middle. The problem with this is that there's one place for hackers to attack, and it's more easy to fail if there's a natural disaster, such as a flood or storm, or human-caused disaster, someone fails on the backup or a power failure. And also, the central entity can change the prices or change the rules anytime. This is as opposed to what blockchain has worked on, is a decentralized system, so it's spread out or distributed on lots of computers. Note there's no central server in the middle of this picture. And every computer on these nodes on the outside edges have the same copy of the ledger on many computers. So this is known as peer-to-peer. This system is much more resilient to attacks and failures. And also, it's not prone to the changes of one entity. All right, so now we know what the definition of blockchain is. Let's see how it works. So let's say there's a ledger, which is basically a transaction keeping Bill sent 10 or 15 amount to Alice. Great, we now store that in a safe. I'm just using the physical analogy, and the combination lock on it is the cryptography part. So cryptography just secures the data. It's very easy for you to open if you know the combination and very difficult to hack if you don't. And we're storing a ledger of Bitcoin instead of US dollars here. All right, so what is this cryptography thing, the analog of the combination lock? Well, it's basically digital math that's very complicated. Encryption just means it takes the process of converting ordinary information, plain text, into unintelligible text, called ciphertext, and vice versa, called decryption. So the Nazis built this awesome thing in front of you called an Enigma machine, where you just type in stuff with that keyboard, and then the coils up top would convert it into gobbledygook and the code. They thought it was unbreakable, and it virtually was. Thank God the Allies had Alan Turing, and he figured out the British code breaker and built the first modern computer to crack the Enigma code, which arguably was critical to the Allies winning the war in World War II. And this was dramatized in an awesome movie, Imitation Game, so highly recommend you watching that. Well, this field of cryptography has advanced tremendously with computers and its need for security on the internet. So when you see HTTPS, for example, on your browser, that means it's a secure connection using some extremely sophisticated cryptography. Well, let's take an example with the check analogy. So if you were to send, Bill was to send $15 to Alice today, he would write a check and it would be routed to his bank, the central server, to record it. So what if we replace that with the digital world? So instead of dollars, we'll replace it with Bitcoin. And instead of Bill physically signing the check with his pen on a piece of paper, we'll use his private keys to generate this cryptographically complex hash. And instead of routing it to his bank, we will publish it to the Bitcoin public ledger. Instead of a centralized bank storing the information, we will use the Bitcoin public ledger. And if Alice wanted to confirm that Bill really sent it, she could go to this public ledger and use his public keys to confirm the transaction. So what happens when these transactions are published to this Bitcoin network? Well, these bunch of transactions are bundled together and put into a block, and then they're published up to this decentralized set of servers, and these are the miners of this Bitcoin network, and they start what's called this mining process, which is really a race to solve this cryptographically difficult math problem. And they're trying to find an acceptable answer. And this race takes about 10 minutes. It's set up to run about 10 minutes. And the race uses a ton of electricity and power and servers to solve these problems. All these networks have these banks of computers. And the winner of this race gets some Bitcoin as a reward for buying all those servers and using all the electricity to run those servers. The acceptable answer is the combination that seals the lock, and this is called the mining process. And then the race continues, it begins again for the next set of transactions. So let's go one step deeper on this cryptography. In the Bitcoin network, they use this cryptographic function called SHA-256. Well, what is that? It's this really incredible cryptographic function, this math function, where you can put any set of data in. So let's say you take this cat2 JPEG, which is 1.21 megabytes of zeros and ones, or you take the MP3 of Imitation Game, or you take the entire Library of Congress, doesn't matter what the input is, and you pump it through this cryptographic hash function, and the output is always this 256-bit long. As long as the input's the same, the output will always be exactly the same. However, if you change one little whisker of this cat picture, the output is completely different. If you change one bit of the MP3 file for the Imitation Game, the output is completely different. So it's a one way in that it's easy to generate the output, but it's very hard to reverse engineer to get to what the input is. Modern computers can't figure it out. There's a theory that quantum computers can maybe figure it out, but for today, this is an incredibly secure cryptographic function. Okay, so let's go back to this mining process and weave in this cryptographic function that we just learned about. So let's add in SHA-256. So there's this ledger up here, and we publish it up to the Bitcoin network, and the miners start working on it. So we take this ledger and we want to run it through the SHA-256 function, and they use this thing called a nonce. Remember I mentioned that earlier. It's a counter. They just keep on running up until you find a solution. And the solution today is arbitrarily defined as a hash with 18 leading zeros. And over time, they'll make it more complicated by adding more zeros to this requirement. So the miner who finds this hash by incrementing this nonce on this ledger until they find this answer is the winner, and they get currently 12.5 Bitcoins. So as we mentioned earlier in the cryptography section, this hash is very hard to find. It takes a lot of mining power, but it's very easy to verify. So this whole process is called proof of work. So what is this proof of work and why is it necessary? Well, we'll remember that the problem and the benefit of the Bitcoin network is that it is distributed. The advantage is that there's no central authority, but the disadvantage is also there's no central authority to decide which is the proper ledger, which is the ledger that we should all work off of. So they use this math formula called Byzantine fault tolerance. And that's a really pretty cool method. So allegorically, it's an example to if a bunch of generals were attacking this walled Byzantine city. They will win if they all attack at the same time, a coordinated attack. However, if there's some traitors among the generals and the messages are being sent by horses around and they can't trust the messages, if they're uncoordinated, they will lose. So how do the generals know which messages to trust and which ones they don't? So that's called the Byzantine fault tolerant problem, and they have really complicated math that solves this problem, and that's what Bitcoin uses to solve their problem of how do they trust all these decentralized nodes are working together to get the proper ledger. So we're using proof of work, builds a consensus model using BFT math solutions to get consensus on what is the real ledger. Okay, so through proof of work, a bunch of computers on these nodes are racing against each other to find this very complex winning hash, and then that seals this block 100. Great. Now this is called blockchain because we take this hash of 100 and use it as an input with the ledger, with the nonce to calculate this new winning solution. So I didn't mention this previous hash in the previous examples, but that's another input and one of the very ingenious inputs. So as we remember, any little change to this SHA-256 input massively changes the output. So if someone goes back to block 100 and changes a little thing, so instead of Bill paying Alice 15, he changes it to 100, then you can see that it would immediately change the hash output of block 100, which would then change the hash of block 101, and so on. So as we move forward, any changes in the previous blockchain would affect anything in the current chain. So anything all the way back to block 99, 98, 97, anything changed there affects the current block. This brilliant method of including the hash of the previous block is where we get the name blockchain, and that's why blockchains are considered immutable, unchangeable. So we've talked about what blockchain is and how it works. Let's talk about the benefits of it. One is greater transparency. All the nodes on this network has the same copy of the ledger. You don't have to trust someone else. You don't have to say, what's your ledger say versus my ledger. Everyone has the same ledger. The oxymoronic phrase of this blockchain is they call it a trustless society. You don't have to trust anybody because it's so transparent. Second is enhanced security. All that encryption that we talked about it. The records are all digitally signed. We use this Byzantine fault tolerant, the BFT system, to ensure consensus with that proof of work before a ledger is confirmed. Transactions are encrypted and linked, as we showed in that blockchain, and data is stored across a wide network of computers, so there's much less risk of one server being hacked or failing. There's improved traceability, so every transaction is recorded and is immutable. It cannot be changed. We showed that earlier. You change one little thing and the last node will show you, the last block will show that it's been tampered with. So this audit trail verifies authenticity and helps fight fraud. There's increased efficiency and speed. Everyone has a copy of the ledger, so you don't need a middleman to wait for the middleman to do the update. Digitally and automated, you cut out the paperwork and you remove the human errors. And finally, is reduce costs. Cutting out the middlemen like Visa and PayPal, who are in the middle, reduces the costs. You're sending directly from node to node. Let's take an example of how blockchain would be used in the real world, how it would help. So let's say supply chain management. Today's world, every entity along this chain of getting the product from the factory to the retail store, there's a lot of steps, a lot of entities touching it. Today, everyone has their own ledger, their own accounting of what has happened. There's a lot of paperwork that needs to be passed around, a lot of billing and shipping and payments, quality control. All these things, everyone has their own record of it. So when something goes wrong, there's a lot of finger pointing. It's hard to figure out who's right and who's wrong. Now, if we move it to this blockchain world, everyone stores all the data on one central blockchain ledger here in the middle. So as every transaction happens, everyone publishes their information up into this secure ledger that we've shown is immutable. So it's transparent, it can't be changed, it's encrypted, and it's distributed so nobody has one failure point, it can't be hacked in one place. This is all great stuff, and this is just one example of using it in the supply chain management. There's literally an infinite number of use cases that we could be using blockchain in the real world. And that's really why I'm excited about blockchain as the technology versus just Bitcoin as the currency. So we've come full circle. What's the value of a Bitcoin? Right now it's around 6,000. Its height was around 19,000. Is it going back to zero? Is it going to go up to $1 million, as some people say it could go to? Who knows? But what is interesting is the technology underneath called blockchain. We've shown what blockchain is and the power of it and how it could be used in the real world. We're like in the early 1990s of blockchain as the internet was in the 90s. We couldn't have predicted Airbnb and Uber being used on the internet, so it's hard to predict what actually we'll be using blockchain with in the future. But it's very interesting technology, it's very powerful, and I think there's an infinite number of use cases for it. So it's a great time to learn about it. I hope you found this video helpful, and I'll talk to you later. Bye.